Hi, everybody. I'm Chris Funk, checking the time, and I'm going to be talking today about FuseNet's integrated drought early warning system. This is a presentation that was also supported by my colleague Kim Slinsky and Amy McNally. And Kim and Amy work with the University of Maryland and NASA to support food security early warning as well. And happy Earth Day. So the Famine Early Warning Systems Network was established in 1985 in response to devastating famines in East and West Africa. More than 1 million people died in Ethiopia. FuseNet is now a leading global provider of timely, accurate, evidence-based, and transparent early warning information. And FuseNet provides integrated food security forecasts for outcomes 6 to 12 months in advance. The figure shown here in the middle of this slide is integrated phase classification for Guatemala that was just produced for this month. And you also have estimates of the population at risk. And basically, the IPC classification is a universal standard that lets us compare food insecurity in different parts of the world. And essentially, if you're in the crisis stage, you really need humanitarian assistance. If you're in an emergency, you're really in need of help, or you're likely to face famine. And sometimes people get to the famine stage. Right now, things in Guatemala are stressed, but not too bad in general. The work of FuseNet, is really important because we're seeing a big increase in the number of people in need of humanitarian assistance, and we're facing starvation. In 2017, FuseNet estimated that there were about 70 million people in IPC3 crisis phase or worse. That number rose to 129 million in 2023, and is probably even greater than that now. Yet, in the face of that increase in food insecurity, the number of people dying due to starvation, has gone down since the 1960s and 70s. And, while it's a big source of disruption, political instability, and suffering, we are managing to keep the number of people dying from starvation to a minimum. And it's a pretty grim business, but we've gotten really good at tracking droughts and their likely impacts on people. And that's what we're going to talk about today. The FuseNet multi-agency science team is a really exceptional group of experts from the U.S. Geological Survey, from the Climate Hazard Center here at the University of California, Santa Barbara, from NASA Goddard, and from NOAA, CPC, and Physical Sciences Laboratory, all working together to provide drought early warning information to the Famine Early Warning Systems Network. And today we're going to mostly talk about work that's being done at the Climate Hazard Center and at NASA with their hydrologic modeling. So, of course, we all love satellites, and we now have a really robust constellation of satellites circling the Earth, providing us information about rainfall. And we can take that data and transform it into precipitation estimates, like the Climate Hazards Infrared Precipitation with Stations, shown here for the 2025 May to August season, where there was really anomalously dry conditions over a lot of Central America. And this information can be passed along to our friends at NASA, who use it to drive the NASA FuseNet Land Data Assimilation System hydrologic model that translates precipitation deficits into soil moisture deficits, shown there on the right, indicating really parched conditions in northern Guatemala. As Ethiopia mentioned, we are really proud to release version 3 of the Climate Hazards Infrared Precipitation Station database. And there are two main pieces to CHIRPS. One is a set of geostationary thermal infrared cold cloud duration based precipitation estimates that go all the way back to 1981 to the near present. That's the CHIRP. And then we blend in station data from many partner agencies, and I'll discuss that a little bit more in the next slide. And between CHIRPS version 2, shown with the black line here, and CHIRPS version 3, shown with the red line, we have really increased the number of stations going into the CHIRPS, particularly in the Americas, which is really great. And the new paper is just coming out in Nature Scientific Data. There's the link there. And of course, you can get it from our website. And we have lots of tools for analyzing it. So one of the things that's really neat about CHIRPS is, it's a public good supported by a lot of people. And so we have many institutions from the Americas who are donating, giving, sharing station data that goes into the CHIRPS, marked there with red asterisks. And then in turn, we really provide the CHIRPS data and the tools to analyze it. And so, everybody wins. And this is a really great foundation for tracking droughts in the Americas and Africa. One of the things that we've done over the years is think about how to fit together multiple pieces of information to track droughts, right? Droughts are complex, multi-scale hazards, and we have developed complex multi-scale monitoring systems that begin with long lead climate forecasts, use weather forecasts going out 2 weeks or now maybe even 45 days with subseasonal predictions. We have near real-time weather observations, and then CHIRPS final data, which is enhanced with really high quality station observations. Then we have satellite vegetation and hydrologic and agricultural modeling information that can all be combined to give us multiple chances to anticipate droughts. And typically we might begin with a long lead concern related to something like El Nino, and then at the end, do something like a detailed NDVI analysis after the fact showing how bad things are. And for FuseNet, we have gotten really good at working across this scale. This drought early warning and forecasting book talks about that. It's pretty pricey, but a lot of it is available for free at that link at the bottom of the page. So if we think about how we work through this multi-scale outlook process, we can pull some text provided by our friends from NASA to the April Food Security Outlook meeting that happened last week, where they're saying, hey, watch out, we've got an El Nino coming. We can go into the CHIRPS archive and pull rainfall for May to August from Central America for some recent El Nino years, and see that in many of those years, in Northern Central America anyway, Guatemala, there was frequent dryness. So we're kind of putting ourselves on alert for that. If we make similar maps over Northern South America, you can see some concerns for sure in years like 2015 and 2023, but less widespread rainfall deficits in years like 2002 and 2004. So there's a concern there, but perhaps not quite as coherent of a climate signal. We can then kind of go one step further and look at downscaled global ensemble forecast system precipitation forecasts. So what we've done here is take these GEFS weather forecasts, quantile match them to the CHIRPS 3, and map them at 0.05 degree resolution. We can express those values as precipitation anomalies So this would be April 17th to May 1st rainfall forecast at 0.05 degrees, expressed as anomalies. And you can see that in northwestern South America, we are concerned about pretty big rainfall deficits. We're also seeing pretty dry conditions likely to form over the southeastern United States. We can also just look at recent observed rainfall from the CHIRPS 3. This would be from March 11th to April 10th, so basically the last month of precipitation up to the 10th. And, you know, we see some pretty big rainfall deficits in Western Colombia. We see some moderately big deficits over the southeastern United States. And then we can do something really cool and take that precipitation and run it through the FuseNet land data assimilation system and share the results with Mario Rodriguez, who's our FuseNet scientist for Central America. And, you know, his most recent assessment is that right now things are doing pretty well in Central America. And he can also look at satellite vegetation and also come to the conclusion that for now things look pretty good, and then feed this information onto FuseNet. In terms of drought monitoring, we can take our downscaled forecasts from the GEFs, our recent observation from the CHIRPS, and put them together in what we call early estimates. So we basically would have observations going all the way back to the 11th of March, and then forecasts carrying us through the 25th of April, and giving us a kind of integrated picture of where we might be seeing large deficits. And we look like kind of Western Colombia is really emerging as a big drought hotspot, also perhaps the southeastern United States. And this is a really neat system. We call these early estimates because, you know, it uniquely combines observations with forecasts and is updated in a very routine way. So this is a kind of big meat and potato tool that we use for drought monitoring for FuseNet. We also have the deep historical record from the CHIRPS, so we can take that information and express it as standardized precipitation index values shown on the left, or as rainfall ranks shown on the right, and, you know, make statements like, if this forecast verifies, you know, we're likely to see exceptionally dry conditions over the southeastern United States and Western Colombia. So to conclude, the FuseNet agroclimatology team has made great advances over the last 20 years. We can rapidly combine observations, forecasts, and hydrologic and crop modeling capabilities. And this allows FuseNet to rapidly identify agroclimatic shocks. And the multi-agency FuseNet science team is a great example of how we can collaborate to help safeguard lives and livelihoods. Thank you for your time and attention, and happy Earth Day.